Hello students. So the last video we saw how to insert at a point. Today in this session we will see how we can insert before an element. In the last video itself I have told you what is the difference between inserting at a point and inserting before an element. Okay. Now we will see how we can insert before an element. Let us see what initially I am going to take 2 pointers, previous and current. Okay, that I am calling it as PREV and CUR, previous and current. These are two pointers I am going to take. Then let me declare some variables. One is item, that is whatever you want to, I will tell you. Value is what you want to insert. Item is which element before which you want to insert. That is your item. Right. Next, let us accept what we want to insert. So, see out. Enter the value to be inserted. Okay, I'll accept that as value. I'll keep my node ready. So we all know we are going to call our new node as temp as always. So I'll keep my node ready. How do I do that? Node temp is my node. I will allocate memory for that new node. Okay. Then temp of data will be the value that I have accepted. Okay. Then temp of next is going to be null. Okay. So this is what we do. My node is ready. So this is whatever value I have accepted, that will come here. This is null. Now, what I should accept again? Before which element do I want to insert this? That is what I have to accept. Okay, so I will write enter the element. It is not the position. Element before which node has to be inserted. Node has to be inserted. Okay. Okay, I will accept that as item. I'll accept that as item. So this is the initial part of the code. What we have done, we have taken 2 pointers. I will tell you why we have taken this previous and previous and current. Then I have taken 2 variables, item and value. What is enter the value to be inserted? For the new node, what value you are putting, that is accepted in value. Then I am keeping my new node ready. So I will create a new node temp, allocate memory for that new node. Temp of data, I will put the value that I have accepted. Temp of next is null. So one single node which has to be inserted is now ready. Okay. What I should accept? Enter the element before which this node has to be inserted. Correct. So that I am taking it as item. Alright. So this being the initial part of the code, let us see how the insertion can be done. I will take a simple example as I did in the last session. This is my existing linked list. Start is there somewhere. Okay, I'll put the start here. Start is pointing to the first node. 13, 15, 23, 44. No. This is my linked list that is existing. Okay. Now, before which element you want to insert? The first thing I want to check is if my linked list is empty. You should always check that. How we are going to check? We all know we can check it as if start is equal to null. If start is null, then I write it as cout list is empty. Okay. So if I have to first check that part, if start is null, then we can't do anything. There is no question of inserting before an element. That will never happen at all. So if it is null, then it is empty, and I keep going. Next. Next I have to check if I want to insert before the first element. Let us say we have accepted the element in the variable item. If I have entered item as, let us say, I have entered it as 13. So that means what? Before 13, I want to insert my new node. Okay. So then, what should I check? I will write if star, if, where is this new node? Suppose I have entered 13. Is it the first element? I should check that first. Okay. I will not write this as item. I have accepted this. Before item, I have to enter the new node. Okay. What I will check first, if start of data is equal to item. Means what? My first node itself contains this item. If I have entered it as 13, before this I want to insert. Okay. So how do I do? If this condition is satisfied, then temp is my new node. Correct? This is the new node. Let me say 50 is the value that I want to insert. This I should, if this condition is satisfied, start of data is equal to item. That means before item, before 13, I want to insert the node temp. So I will insert this before here. So what will happen? This has to come here, point here. The start will become this one. Similar to what we did in the last function. So what can I write? Temp of next will be start. Then start will become the new, temp will become the new start. If your item is 13, that means you want to insert before 13. So my new node temp will come here. So this temp of next should point to this node. This node is what? Currently it is start. So we have said temp of next is equal to start. Where should start point to? It should point to temp, because this node will become my first node, right? So start is equal to temp. Now, if there is only, let us say, only one element in the linked list. If this is my condition, this is the linked list that is existing. We do not know what is the linked list that is there. First case, what we saw, if I want to insert before the first element, there may be so many other elements, but I want to insert before 13. Okay, done. It is over. Next, what I am checking, I want to insert before 13. That's okay. But 13 is the only element. So, what should you do? That we have to see. So, that I have to check that as else if start of next is equal to null. That means if it is only element, then this will be null. But here this will not be null. That's why we have not checked. Correct? And start of data is equal to item. Start of data is item. Start of next is also null. That means you have only one element. Here you are inserting before the first element, but first element is not the only element. You have so many other elements. But here you are inserting before the first element, and there is only one node. That is what you are checking. So what will happen again? Temp of next will be equal to start. This node has to come here. Same. Temp of next is equal to start. Start is equal to temp. Return. That's all. Okay. Before the first element. Before the first element. But the first element is the only element. Then this part will. What else you have to check? If you don't want to insert before the first element, your position, let us say you want to insert before 23. Then we have to write another code for this. Let me continue this code. Okay. So we have to see two cases in this. I want to insert before the first element, but there are several other elements in the linked list. That's the first condition that we wrote code for. The second one, what we wrote, we want to insert before the first element, and that's the only element in the linked case. We have seen that part also. Next case we will see where you want to insert before some other element, not the first. Next. So I will now use this two pointers. We have defined two pointers, previous and current. Correct? Now let me use that. So current is equal to start. Okay. Now, suppose I want to insert before 23. I have to traverse up to that. Is it not? In the last video session, we had also taken two pointers there also. S and previous or some S and pointer. Correct? Here we have taken previous and current. So that's all. So while current is not equal to null and item is not equal to current of data. Why I wrote this? Current is equal to start. Correct? So this will be my current. I have to traverse up to 23, is it not? So I should take a pointer. It's like a for loop, a looping variable. So if current is not null, and item is not equal to current. What is my item? I want to insert before 23. So item is not equal to current of data. Current of data is what? 13. So both the conditions are not satisfied. So what will I do? Previous is equal to current. Current is equal to current of next. Why I did this? Current is not equal to null. Item is not equal to current of data. Current of data is what? This is my current. Current of data is what? 13. What is my item? 23. Because I want to insert before 23. So item is 23. So this condition is satisfied. So what will happen? Previous is equal to current. Current is equal to current of next. This one will now become previous. This will become my current. Current is equal to current of next. Next. Again I will go back. Current is not null. This is my current now. Current is not null, not null. What is item? 23. 23 is not equal to current of data is what? 15. So both the conditions are satisfied. So I will again do this. Now again what will happen? This will become previous. Current is equal to current of next. So that will become current. Now current is not null. Item is not equal to no. Item is equal to current of data. So it will come out now. Because I want to insert before 23. 23 is my item. Item is what? 23. Current of data is what? 23. So this condition is not satisfied. Even and I have given. So even if one condition is not satisfied, it will come out of the loop. When it comes out of the loop, this will be your previous. This is your current. Where do you want to insert? We want to insert it here. That means I will write it here again. This is 15. This is 23 and you have something. This temp should come in between. This is the value. This I have set it to null. This is my temp. This is my previous now. When I come out of the loop, what is the condition? This is my previous. This is my current. Okay. Now this I want to insert before 23 I said. So this should come here in between this and this. That means this link should go here. This link will not exist. It should come to this. That's how you are trying to insert. So how can I code that? How can I code? I can write. First I will say what? When I come out of the loop. Why I came out of the loop I don't know. Whether this condition was not satisfied or this condition was not satisfied I am not sure. If I say current is equal to null, that means you have arrived at the last node. That means your element is not found. Okay. Whatever item you have given, that is not found. So I will write it as not found. Otherwise, are you getting me? When we come out of this loop, either this condition is not satisfied or this is not satisfied. That means either current becomes null or item becomes equal to current of data. I am checking for the first case now. If current is null, that means what? You arrive at the last node, which means your item is not present, so you can't insert before that. Else, what's the next condition? Item is equal to current of data. So when item equals to current of data, this is what happens. I have to link this to this current. This is my previous, this is the current. This will come here. How can I code that? Temp of next. How do you access this? This is nothing but temp of next. Temp of next should go to, what is this? Current. So I will write temp of next will become equal to current. And what is this? How do you access this part? Previous of next. Previous of next will come to temp. So previous of next will be equal to temp. Okay. So that is how you try to insert before an element. So first we check if the list is empty, then you are not going to insert anything. Then we check for if your element is the first position. There we check two conditions. That I want to insert before 13 and there are many elements in the list. That's one condition that we check. Second condition what we check? I want to insert before 13 and that is the only element. Okay, that is the second condition that we check. Third condition what we are checking? Any other position other than 1. So in that case I have to have a loop wherein I move up to that particular point before which you want to insert. That's why I took previous and current as 2 pointers. So as long as this condition is satisfied, we go on, traversing all the nodes. Previous will become current, current will become current of next. When the condition satisfies, we come out of this loop either because this is not satisfied or this condition is not satisfied. If this is not satisfied, if current is null, that means you have already reached at the last node, but the element is not formed. That's why we have written element not formed. This condition is satisfied, that is item is equal to current of data. That's why you have come out of it. That means I want to insert before this position. So temp should come in between 15 and 22. So how do I write this? Temp of next will become current. That's why we took 2 pointers. Because we should be able to access these two nodes, previous and current. So temp of next will become current, previous of next will become temp. Is that clear? So these are the conditions. These are the conditions that we have taken in order to check that, in order to insert. How can we insert before an element? Is that clear? So we have seen how to insert at the beginning. We have seen how to insert at the end. Insert at a particular point, at a position. Insert before an element we have seen. Next, let us see how to display. Okay. Once we finish display, I will go to the deletion part. Let us see how we can display the linked list. Okay. Now let us see how we can display the linked list. I have written the code here already. So let me explain to you step by step how we can try to display the linked list. Okay. Now let me take a simple linked list. Let me say I start with start. This is the linked list I want to display. Okay. So I am taking a pointer variable temp as a pointer, that's all. We are not creating any new node because we don't want to insert anything. What you have to check first before you display, we have to check whether the list is empty or not. If the list is empty, then we obviously cannot display anything on it. So how do you check for an empty list? Start is equal to null. Start is a pointer which is going to hold the address of the first node. So before you insert, we initialize start as null. So if nothing is there in the linked list, then start is going to be null. So if start is null, then you display list is empty and you return. That's all, because we can't display. The next condition is there are some elements in the list, so we want to display that. So I will take a pointer variable temp. Temp is equal to start. That means I am going to start at this location. Temp. I have to go on displaying each one of them. Correct? So while temp is not equal to null. That's why are we checking? Because we have to go up to the last node. Right? So while it is not null, see out temp of data. So now this is the temp. Temp is not null because it is pointing again to the next node. What is temp of data? Temp of data is 23. See out temp of data means it is going to display 23. Then what I did, I have put an arrow so that it looks like linked list. Okay, that's why I did that. Then temp is equal to temp of next. Temp is equal to temp of next. Temp of next is what? This. This will become my new temp now. Again I am going, it will go back. Is temp is equal to null? It is not null. So again you are going to display temp of data. What is temp of data here? This is my temp. What is temp of data? 33. Again I will put an arrow. Again I go back. Is temp is equal to null? Yes. So you are going to display. Wait. So temp is not null. So you will display temp of data. So what is temp of this? This becomes your new temp, right? Not this. So what is temp of data? 40. Temp is equal to temp of next. Again it will come here. Temp is equal to temp of next. What is temp of next? Null. This is null. So temp is null now. This condition is not satisfied. So it will not get into this loop. It will come here. See out null. So I will do this part and then I will write it as null. So that which indicates your end of linked list. So this is why I have, this is a simple function for displaying the linked list. Okay. So we take a pointer variable temp. First we check whether the list is empty or not. If the list is empty, obviously you cannot display anything. So you can't display start is null, list is empty, return. Then otherwise I take a pointer variable, I initialize it to start. So I will start from this node temp. If temp is not null, you are going to display temp of data, that is the data, followed by an arrow so that it looks like a linked list. Temp is equal to temp of next. So you go on displaying, checking this condition for every node unless you reach the last node, that is null. Once it is null, you will come out of the loop and you will display it as null. So your linked list will be displayed something like that. Right? So this is a simple function for display. So far in single linked list, we have done with insertion at the beginning, insertion at the end, insertion at a point, insertion before an element, and we also have seen we also have seen display function. So next video session, I will be teaching you how to delete nodes from the single linked list. Okay, till here probably you can also start trying in your at your end. You can start trying because this is one of your lab cycle program. Okay, I'll see you all in the next session. Thank you.